that. What I'm going to talk about today is I'm going to talk about a couple of things. I'm going to talk about, first of all, the very fact that realistically, I should probably stay on the screen. The very fact is, realistically speaking, things they're going to get at. Locking it up is all well and good, and most of what we're going to be doing here is going to stay in the lab somewhere. But things are going to get it. I'm going to talk about the floodgates that are going to happen with that. The floodgates of the sort of the effects on the ecosystem, the floodgates of the effects on sort of the genetics research industry, and what that could mean to humanity in a negative way. Then we're going to get into Flash, and then I'll be happy. So to start up, sort of like locking up won't work. I mean, we've seen every time we do anything in society that we supposedly are going to keep locked up, it doesn't work. Like, it just doesn't work. Nothing ever stays hidden. Nothing ever stays locked up. Computer viruses get out. All of this happens. You have outbreaks of things that were supposed to be locked up and weren't supposed to be. You have things like the U.S. Army flying nuclear weapons halfway across the United States, completely against every single rule they have. When you have organizations, especially government organizations, stuff goes wrong, and it's not something that we like, and it's not something that we enjoy, but they're going to get out. And that's where I'm going to get into sort of, okay, do you not agree?
All right, but sir, even though we have computer viruses that get out, we still let people have computers and write programs.
Absolutely.
We see that there are other benefits from them.
No, absolutely. And we don't have anything against knowledge or the development of the knowledge of how to experiment and how to do these genetic modification experiments. But what we say here on side opposition is we need to do it incrementally. We need to do it carefully, and we need to do it without making the giant mistakes that have been made with technological leaps in the past. So I'm going to talk about sort of the genetics part of this. We want the steady and incremental change, because if the floodgates are open, people are going to do all kinds of things. They're going to be experimenting on everything. You're going to get half pony, half monkey monsters, and you're going to have to deal with them at some point. And these half pony, half monkey monsters can be a danger to the ecosystems if they get out. But let's talk about sort of, realistically speaking, some concrete examples of when societies come up with sort of technological changes that desperately should have been looked at and analyzed before we started using them. CFCs, DDT, even X-rays. When they first invented the X-ray machine, they were X-raying everything. They were X-raying their vital organs over and over and over and over again. And you got all sorts of people getting all sorts of cancers. This is generally bad because they didn't stop and think, well, what's the effect of X-rays on the body? Oh, you're radiating the body. So no matter how careful we are, we're going to make mistakes. And so when we're doing this, what we should do is make the small mistakes and learn from those and not make the big mistakes. So societally, we don't screw up our planet any more than we already have. Don't you agree?
But since we made those big mistakes and we did make those leaps and bounds in knowledge, we're able to use them much more effectively now, much faster than if we went.
Faster than we did. But we're also destroying our world, and CFCs are part of that. The greenhouse effect, all of that is because of all the things we've been doing with these scientific advances, and we're destroying our planet through it, and we may not survive the next 100 years because of it, and I think that's a serious problem, that we should now look at the future and say, geez, this thing is even bigger and more scary and has more possible effects. Maybe we should take this one slowly and actually be careful about it, instead of allowing scientists to go willy-nilly and create these half-pony, half-monkey monsters. And that, realistically, shouldn't be that much to ask for, ladies and gentlemen. It shouldn't be that much to ask for, because it should be, scientists, be careful. And we don't think that if you remove all regulations, scientists are going to be careful, because they like to experiment on stuff. They like to create new things. Knowledge is great, but let's do it carefully. So getting into sort of the next point here about sort of the ecosystem and what are the effects on this. You're creating things, especially plants, that are specifically designed to dominate. Now, yes, Ian came up and he told you this wonderful story about how we're genetically modifying things in such a way that they won't be able to effectively operate in the wild. But why then did Monsanto sue an Indian farmer whose crops were being overtaken by Monsanto wheat? Like, what ended up happening was the seeds fell off of the chaff, because they do that. Just because we genetically modify them to fall off a little harder doesn't mean they're not going to fall off when there's a good wind gust. They blew across into this farmer's field. They started growing in his field. We've all heard the story. They started growing in his field, and then Monsanto sued him because they started growing there. He didn't do anything. All he did was plow it and use it because it was there. Who cares? But they still sued him because they couldn't control their own product, and it got out. And so these genetically modified crops are still getting out. So it's not like they're not capable of existing in the wild. It's not like they're not capable of dominating the wild, because that's what they're specifically designed to do. If you've got something that's designed to grow for 10 months of the year instead of 6, that's what's going to happen. That's going to be the thing that takes over the ecosystem, and you're going to destroy it. If we've already seen invasive species going into places like Australia with the frogs and whatnot, if we've already seen those massively damaging ecosystems, what's going to happen when we're going to do it with bacteria and plant life and even possibly animal life that's specifically designed to dominate and not just something that's happened through power of creation over millions of years. These things are going to get in there and completely wipe out local atmospheres, local ecosystems, and that's one of the big dangers that we're going to have. And that's why we need to do this incrementally, slowly, and carefully. Yes, they say they're going to keep it locked up. Do we really believe that society can actually keep something like that locked up? Have we ever really managed it before with anything? So let's allow these studies, but let's do it carefully and under the watchful eye of the government, because the government can keep people in line and not do crazy things like half pony, half monkey monsters. So getting into a little bit of clash here. Ian came up and he rose this sort of radiation point, this idea that, well, before we came up with genetically mutating things, we were just irradiating them and watching them grow. Well, we in opposition don't think that the other way we do things, that things were done is bad, is a good argument for doing something else that's bad. We think that you should simply say, no, don't irradiate crops, and let's modify the crops in the old-fashioned way that involves crossbreeding and all that other jazz that they used to do. Let's do it in the normal way, and let's do it in the way that we understand and know what the results are going to be, not in a way that we don't know the results. Ian even himself even stood up and he said, the knowledge of this is absolutely vitally important because it'll allow us to do bigger things even after. Because we don't know what happens when we modify things, and we don't know the results of it, and we don't know it. And he even said the words, experimentation is dangerous. And ladies and gentlemen, that's why we outside opposition say, experimentation is dangerous. Let's do it incrementally, and let's know what we're doing before we get into it. I don't think that's too much to ask for the reasons that your locking up isn't going to work. You're going to open up all these floodgates that scientists are going to be able to do whatever they want, whenever they want, with whatever they want, as long as it's not human. But with it, whether it's a pig or a monkey or a pony or a wheat chaff or anything like that, they can do it. And that's going to be a problem when you get all sorts of mutations, all sorts of crazy stuff coming out of the works, because even inside government has admitted, we don't know what happens when we start doing this. So why should we start doing this on massive scale when we should learn what's going to happen on a smaller scale first so we can apply it to the larger scale? And that's what we really say outside opposition, is let's do this slowly and carefully so we don't screw up the planet like we already have with so many other technological advances in the past.